Now we're going to go over these special products. So it is extremely common to see this setup where you have something plus something and then an outer square, or something minus something and another square. What is this really? This is saying A plus B is going to be multiplied to A plus B. Hence, we have a binomial being multiplied to a binomial. So what would we do? We would do A times A to get A squared. Then we do A times B to get AB. Then we do B times A to get BA. Then we do B times B to get B squared. Now going back to lecture 1, A times B and B times A are the same thing because you're just multiplying and you're just switching around the terms. So essentially this is just AB plus AB. This becomes 2AB. So you end up with A squared plus 2AB plus B squared. And so a lot of times you can just memorize this formula. So anytime you see this, you could just jump to this step without having to do this extra step. Do you have to memorize it? Not really. If you see, let's say 3x plus 1 squared, you can still split this into 3x plus 1 times 3x plus 1, and then FOIL or do the binomial distribution as you would. But if you do have this memorized, it saves you one step and you can get to solving your problem maybe a few seconds faster. So this is more of a preference. It's not something I would require that it's be memorized, but it is very useful to have it memorized. And generally when I solve these problems, because I've done them so many times, I have naturally ended up memorizing this formula. And so it just saves you a step here or there. Okay. Notice the format is exactly the same. You have the A squared term, you have a B squared term, in the middle you have a 2AB. The main difference is the sign here. This sign will match the sign here. So it's actually fairly simple to memorize if you decide to do so. And but you also want to make sure that you can implement it appropriately. And if not, again, this is always the safest route. So let's look at this. We have 3x plus 7 squared. Again, if I go the standard way, this is equal to 3x plus 7 times 3x plus 7. Okay, so I'll do 3x times 3x to get 9x squared, 3x times 7 to get 21x. Then I do 7 times 3x, 21x, 7 times 7, 49. And then I add these. I get 9x squared plus 42x plus 49. However, if I want to use the formula, I'll write it up here. The formula states a squared plus 2ab plus b squared. So what does that tell me? Okay, well here the a is the 3x and the b is the 7. So I'm going to end up with 3x squared plus 2 times 3x times 7 plus 7 squared. Okay, well this is 9x squared. This is 2 times 3, which is 6. 6 times 7 is 42. And then we just do 7 squared, which is 42. Okay, so whichever route you take, the final result is the same. Okay, What happens with negatives? Again, same idea, just have to be a little careful because you have a negative sign. Now, with the special product, this is going to be a squared minus 2 times ab plus b squared. So I'm going to go about this using the formula. Again, the a is the 3x, the b is, in this case, b is negative 7. So we'll have 3x squared minus 2 times 3x times negative 7 plus negative 7 squared. Okay? So again, notice when you have a negative, your b term is negative. So here we have negative 7, here we have negative 7. Right. So now 3x squared becomes 9x squared. Here you're going to have negative 2 times 3, which is negative 6. Negative 6 times negative 7 is positive 42. And then finally, negative 7 squared. Oh, sorry, I made a mistake. The actually the b is the negative you don't have to worry about because this formula already took care of it. So we actually don't need this here. This should stay negative. When you have the formula, that negative sign here takes into account that you have a negative here. Okay. So the way I was solving this, I was using the original form of the formula. So then what happens is in that situation, if you made b negative, then this plus sign would became negative. But if you have this format memorized, then a just stays 3x and b stays 7, and then that negative is already associated to this one. Okay. So this would actually be just negative 42, and then we have the 49. Always good to double check your work if you're unsure. So remember, you could always, again, do it this way, where you just split this into that, and then take advantage of the FOIL method. Okay. That would get you to the same place. All right. Something else to keep in mind is two things being added or subtracted with this outer square. It's not the same as squaring them separately. Okay, so this is going to make more sense with the example. So for example, if I had 3 plus 2, and then I have a square like this, well, this is saying 5 squared, and this is 25. But if I had 3 squared plus 2 squared, this gives me 9 plus 4, which is equal to 13. So notice these are not equivalent. Okay. So outer square does not mean you can distribute like this when you have terms being added or subtracted. So if we had 3x plus 7, as we did in the earlier problem, this is not equal to 3x squared plus 7 squared. These will not be the same.